Okay, quickly we're going to talk about the Pi Repeater 2X that comes fully in a case, but this information also applies to the standalone board that you may purchase if you already have your Raspberry Pi or have some other application where you don't necessarily want our case. What applies to one applies to both in this situation. So the first thing we're going to talk about is the cable orientation. Now, looking at this cable, you'll see that there's a brown cable, and that indicates pin number 1. And this particular orientation that you're seeing here, that is always going to be to the bottom right, and that applies for port 1, port 2, GPIO, and the ADC ports. Certainly important to make sure that those are also oriented correctly as you assemble your hardware if you ever have to disconnect it or otherwise starting from scratch with the loose board. So next thing we want to talk about, and I've moved these cables aside just so it's easier to see here, are the COS-COR switches. Now right now these are in the up orientation. It might be difficult to see in this video. With this cable out of the way, you can see those. But when they're in this orientation, this means that the COR-COS signal coming from your receive radio is active low. Let that complete real quick. Okay, so as I said, this is in the active low, and this is dependent on your radio. Most radios are active low, but not all of them, so certainly something to understand about your receive radio as you're hooking this up. Now I'm going to press the monitor signal on my receive radio to demonstrate what the LEDs should do when you get an active low in this situation, COS signal from the hardware. So difficult to see. We'll turn that off for a moment. Difficult to see, but the green LED has turned off. The first red LED here is the COS indicator, and the next LED here is the push-to-talk signal that's driving your transmit radio. When you let off the monitor, the COS turns off, and with an appropriate delay as set in SVX Link, the push-to-talk will turn off. Now, when the radio identifies, or excuse me, the controller identifies, the push-to-talk will also turn on its own and identify as you just saw it previously. So turn that back on here. Okay, so that's the basic signal, and the first LED, the COS-COR, will work regardless of whether or not the SVX Link application is running or not. So it's a good check to know that your COS signal is hooked up to the connector properly, and also your push-to-talk is connected up properly based on this green LED. You may have to make some audio adjustments. We've already done that on this particular piece of hardware, so if yours needs adjustment, please see our other video for that. And with that, I'm going to put this together and we'll start moving into the software. Okay, now we're going to talk about the software that we use to administrate our Pi Repeater 2X. So first, let's look at a few of the tools that we use all the time. So first is Winscp. This is from winscp.net, and the latest and greatest download is usually sufficient, so just get that downloaded, run through the installer, and just do the normal things. Make sure you don't install any packaged software that comes along with it. You just need the base utility. The second one is Angry IP Scanner, 3264-bit. This is a very reliable tool that I'll actually show you how to use here in just a moment. So go ahead and take the time now and get that downloaded and installed and have it ready to go. And the last one is Win32 Disk Imager from SourceForge.net. We don't actually recommend using the latest and greatest on this one just yet. The version 1.0 release is a little buggy when it comes to Windows 10. So we actually recommend dropping down to this files. There's an archive, as you see here, and then grab this 0.95 installer. It has a little bit better error handling in the Windows 10 environment that got broken in the 1.0 fix. So I'll minimize that. And now I'm going to show you how to use the Angry IP Scanner to find the IP address of your Pi repeater. So you'll see a couple things here. The IP range is 192.168.1.0 to 192.168.1.255. This is all of the IP addresses you normally would have to scan for a local network. And 192.168.1 may change, but this is a very common one, so I would start there. So next thing we're going to do is just run start, and this runs a ping protocol, which is basically going and knocking on every address and seeing if anybody answers. And it runs through this whole iteration fairly quickly, comes back and tells me that I have 12 devices alive within this address, or there's 12 devices that answered. So I'll talk through a couple of these real quick just so that they're not confusing if you happen to look at this and wonder what some of these are. Chromecast is video streaming, so that may cause some network delay as we go here. A Rock64 is another one-board computer that's on my network here. I have a handful of tablets, computers, and other paraphernalia. Raspberry Pi, this is actually not the one that you're going to see unless you have a second device on your network called Raspberry Pi. This is actually my build server that is also Raspberry Pi. I just have not reconfigured the name yet. But the one you're interested in for this video is this Pi Repeater 2X. Now, if you use our images, that'll automatically show up as Pi Repeater 2X with an IP address somewhere over here on this left-hand column. And for this particular instance, we have 192.168.1.15. So that's how you use Angry IP Scanner. So just remember that we're on 15 for this short one. And the next one we'll open up is a utility called Putty. Now this is a standard SSH terminal, widely used. So if you just do a generic search for Putty SSH, you'll get the installer. It's widely available. So we have a 192.168.1.15 address. So now we'll say open, and we'll get this message that asks us to log in. So we're going to use pi lowercase, and the password is all capitals ICS-ICTRL. Sorry, that was incorrect. ICS-CTRL. There we go, had an extra character there the first time. Okay, there we go. Apparently I can't type on the second one either. Okay, so now we're in. So let's talk to a couple of the basic commands that you might use if you're in the console view here. So let me open up this other window and so you can kind of see them. So the first one you should start with is this Systemctl disable remote TRX. And what is this command? So remote TRX is a sister program that runs alongside SVX links. We don't actually use it for applications, and we found that it actually can cause some conflicts at boot time that could cause your repeater to not come online. So we're just going to disable that as a standard part of this routine. So first thing we'll do is run sudo, which allows us to basically have administrator access on this box. The Pi user itself is very restricted. So we'll use sudo, which means do as super user. So it's kind of like the right click run as administrator under the modern Windows. So we'll run that, and we'll say that it removed this. So the next time we boot up, this remote TRX application will be disabled. Now, if you do find that you want to use it as you get more advanced into the SVX Links platform, instead of doing this disable command, you just say enable and it'll turn it back on. But as I said, it does cause some audio conflicts. It'll cause your repeater to not come up, so be prepared for that event. Okay, so now let's take a look at the logs for SVX Links. So SVX Links automatically runs when you power up. So we'll take a log here and make sure everything's looking okay. So we're looking at the log here and we see this particular error. This is exactly what we were just talking to, is that this device or resource is busy. This is because when SVX Links tried to open the sound card, the remote TRX had it and had not released it yet. So now that we've disabled that, we can do a reboot and this error should disappear. But using this tail-f/var/log/svx link will get you into the logs, and this will be a continuous monitoring, so it'll continue to scroll. And if you find you're done looking at that, if you hit Control+C, it'll drop you back out to the console. And Control+C is pretty widely accepted as kind of a master escape within Linux, so kind of keep that one in mind. But before we reboot, we might as well go in and look at the config file. And actually, I need to make a correction here. We want the config file. So we've already talked about the sudo. So what is nano? Nano is a simple text editor that runs in a console. And so we'll use that just to get a brief look, and then after we're done here, we'll do a reboot, wait for it to come back up, and then we'll go over to the Winscp that's a little more Windows user friendly and take a look there. So this is your config file. As you can see, you have some globals. Anything that's prefixed with a # means that it's disabled. Logics. This is a good one to understand. So logics are effectively your channels. So we have a channel named duplex logic, and we have another channel called duplex logic 1. Now the options here that typically are used are simplex logic, the duplex logic, sometimes also known as repeater logic if you're on the main trunk software, but we renamed it to follow convention in our particular builds, and reflector logic. Reflector logic is yet another sister program that allows you to basically have a voice over IP specifically tailored to the XFX link, so it'll handle all of your protocols and things that a normal VoIP system would not do. Most of the rest of the stuff you can kind of ignore. If you want to update your timestamp formats, certainly welcome to do that. This is documented other places, and we won't go into that. Card sample rate. Now we're using the FE-Pi sound chip, and it's pretty particular. It has to be at 48 kilosamples, which is shown here. Don't change that, or you can get some really weird behavior. So the next one is this links. Link is exactly what you sound like. It's linking multiple channels together. So then we have this link definition down here, and we have this connect logics, and this tells the link what logics are connected to what. So in this particular case, I have duplex logic and duplex logic 1 linked together. So anything that comes in on channel 1 will go out on channel 1 and channel 2, and vice versa. We can set some timeouts and other things there. I'll let you read up on that in the documentation. Simplex logic, we won't touch on for right now, but it's basically the same as the duplex logic. Functionally, obviously the behavior is slightly different, but from a config file, it's pretty similar. So quick ones to touch on that'll be of interest is this RX1 and TX1. This defines your later defined channels for receive and transmit. Callsign, this is something you're going to need to update to your specific call or whatever the call of your repeater system is going to be. And this is just a generic field that gets read character by character, vocally or through CW, depending on the config files the config variables we're going to touch on here momentarily. Phonetic spelling, by default, is off in our images, so it'll just read as A, B, C, D. Now, if you set this to a 1, that enables phonetics, so then you'll get Alpha, Bravo, Charlie, Delta phonetics read vocally. Short ID is typically ran on a 10-minute interval, which is you can set down here. And so this enables the voice version of the ID on that 10-minute interval. Set it to 0 if you want to disable the voice portion. By default, we leave CW off because we have the voice on. But if you change this to a 1, CW will also play. And so you can have this as a mix and match. And there's also an option for announcements. And there's a WAV file that we can talk to at some point to where it'll automatically play out on this 10-minute interval as well. Typically, you don't want anything going out on your 10 minutes because it tends to clutter the repeater, but there is something there if you're so inclined. Long voice enable, long CW, and long announcements are the same, but these go out every hour. So these are minute intervals. If you're using the CW, we have the options for amplitude, word per minute, and pitch, also known as frequency for most of us. So you can change how the CW sounds as it's played out. Modules are an important thing. These are basically expansion packs that are added into SFX links for specific features. Help, parrot, echo link is a common one. We leave it disabled just because it's not configured by default, but certainly it should be functional. Voicemail is another one that's not typically used in the US, but there has been some demand for it. We have an A to D module that allow you to read vocally any of the AD channels that are coming through the AD port on our controller. Remote relay is basically a GPIO controller that's done through DTMF. It's named remote relay because it was originally developed for a board that had relays on it. So It's a little bit tuned to relay behavior, but it'll function on just about any GPIO under the hood. Site status is something that will allow you to monitor the actual site health of where your controller is. So it's got digital and analog controls that it can read from. So you can have things like, readings across the air that say, security gate opened, or garage door opened, or, fuel fuel system low, or fuel system refilled, etc., etc. It's fully customizable for whatever you need, and there's several examples there that'll take care of that for you. And module TX fan. So this is a transmitter fan. This was a special request one that we built and have now pushed up into the trunk, where your transmitter might have an auxiliary fan on it outside the regular radio control, and you want that fan to run for some period of time after the transmission has stopped for one or multiple channels. So this is a module that has a countdown timer that's reset every time it detects that a controller is transmitting. And so as soon as all transmitters are done, it'll start a countdown timer from 10 seconds, which is adjustable, driving this GPIO until that countdown timer is expired, and thus disabling the fan after that. So for this particular piece of hardware, we want to get rid of the comma, because that's going to be our last entry. And we're going to disable the rest of these because we're not going to use them on this particular setup. Okay, so time format, 24 hours or 12 hours, personal preference on that one. It'll support both. And for the most part, you shouldn't really need to adjust any of these until you get into kind of more advanced settings. So now, however, we have the receiver one, and type is local. Your little insert would talk to this briefly about what audio channels to configure in SVX link. That was probably a confusing part on that sheet if you're not familiar with it. But this basically defines on what channel 1 of the receiver looks like. So it's using a GPIO squelch. It'll wait 100 milliseconds after the squelch is detected just to get any random blips that might momentarily activate it. And a few other settings that are generally not too exciting for the basic user since they're already configured. GPIO path, it's commented out, but this tells you where in the file system to look for the GPIO if for some reason that ever gets moved. And the squelch pin is GPIO 26. Again, this is something you should never have to touch, but just know that it's defined there if for some reason you want to remap those with a jumper wire or something like that. And we'll just jump down through here. Transmitter, same basic principle. What audio channel is it? We use push to talk as the GPIO. There is Vox options, but because we're using GPIO, we're telling it it's 506, which is on the GPIO expander. Hang times, timeouts, delays, all configurable. And we're now into duplex logic 1, which is basically a clone of duplex logic. So we did make some changes. So we're going to use Control X, and we're going to say yes, we want to save it. Save it away there. Okay, so now that's saved. So now we want to do a reboot so that the remote TRX can get taken care of. And we'll give that a couple moments here to let the system reboot. It usually takes about 20 to 30 seconds, so we'll give it an appropriate amount of time. Okay, so if you didn't see it, I clicked on the banner up here, and with the right click, you can do restart session as it goes idle, or you can duplicate it for your needs. So I did hear it log in and announce that it's online, but for now, let's just verify it, and we can see on the login here. So we've got Pi, ICS-CTRL, all capital with a hyphen, and we're logged in. So now if we click the up arrow, we can go to this tail, and we can see the tail of the log is now clean. We saw it turn the transmitters on to identify, and then turn them off when it was completed. So let's quickly Okay, now that we've done the console side of it, let's hop over to Winscp so we can show the people more familiar with Windows how we're going to do this. So start by changing the protocol to SCP. Enter the IP address that you found. So in my case, it's 192.168.1.15. port 22. User again is pi, lowercase. Password is ICS-CTRL, all capitalization. Now we want to change a setting here to make sure everything works. So we go to Advanced, SCP Shell. Under Shell, we want to change it to sudo su dash. Okay, do that. Log in. Okay, now we're going to navigate to the config file for svxlink. So now it's etc svxlink svxlink conf. Now this looks exactly like what we were just looking at before, but in an environment a little more familiar to Windows users with a GUI-based editor. So this is the simplex logic. So because the logic's up here, none of these are simplex logic. Anything you change in the simplex logic subfolder will not actually change anything about your normal runtime. So you want to scroll down and do the duplex logic and duplex logic 1. So I want to change this to my call sign on both RX and TX. Now if we change those and minimize, and we watch over here, you want to make sure that this actually gets to the completed stage. Otherwise your changes may not take effect, and you'll think you've done something and come to find out later after beating your head against the wall for a while that it didn't actually work. So now that we have that taken care of, we'll log out from that file, and then I'll show you the GPIO just so that you're aware of its availability and what's inside of it. So this is the config file that svxlink used to configure GPIO file. Now everything's pre-configured for our hardware, but if you need to add controller ports or GPIO pins for something like the fan controller or the site status monitor or something, this is a good place to do it. So you'll notice there's a few key things. The system path, just ignore, leave it alone. So GPIO pins that are inputs and have an active high state. So this means that when they're not active, they have a 0 volt state as indicated here, or a 3.3 volt or logic high, depending on what your interface looks like. So the way you put this in is, this is the GPIO number, and normally when they're listed in system, they'll be GPIO 496 or GPIO 497. Well, the GPIO part is assumed in this environment, so you just want to enter the number. So if you wanted to add another one, you'd add a space, and I'll put 512 right now, which is a fictitious number that the Raspberry Pi can't handle. But that's how you add it in to create new ones, as you can see have been done in other places here. So I'll take that back out just so we don't cause any problems later. But anything you put in here will be automatically configured for you by svxlinks. The caveat is, if for some reason svxlinks is shut down or you terminate it while the Pi is still running, anything configured in this file will also be reverted back to a non-configured state when svxlinks exits. So just be aware that that's the environment. Now for our controllers, we have a handful of files. The 496 and 497 are actually pins that are used in the site status monitor example that's provided with the code. So that's why those are there, just to kind of get people started. But 23 and 26 are the cosign, or not, excuse me, not the cosign, the COS/COR inputs that indicate that the radio has decoded successfully a transmission and wants to get svxlink's attention. So in our hardware, these are always active low signals, meaning that they're 3.3 volts when nothing is happening, or 0 volts when the signal is active. Now, your radio may provide both. We provide a switch on our hardware that allows you to select. But through all the circuitry, when it's said and done, it's an active low signal that comes into the Raspberry Pi. Now, the 506 and 507 are active output, and they're active high, meaning they have a logic high when the signal is active. Now this might be a little confusing because our push-to-talk hardware, the pin that actually is exposed on the connector is a switch to ground signal. So this is an inverted logic that might not make sense, but essentially the logic goes through a FET controller that acts as a logic inverter. So when you drive an active high signal on pins 506 or 507 for the push-to-talk, it turns on a transistor, or think of it like a relay, that switches the push-to-talk signal from the radio to ground. So just be aware that that's there. And we have no current use for GPIO out that are active low. but those are available as well through this config file. So that's the config file in a nutshell. Pretty straightforward. The hardest part is figuring out what GPIO you need. But once you have that, everything else within this file is pretty straightforward. So we don't want to save changes to that, just in case I did type something that I didn't catch in there. Now you can scroll down through and as you'll see here, you have duplex logic 1 uses RX2 and TX2. And these modules can be different between channel 1 or channel 2 or duplex logic 1, duplex logic 2. It's configured on a system by system basis or a channel by channel basis depending on what your hardware is set up as. And you can just copy and paste these, incrementing the number is appropriate. So if you were to create a new one, you'd want to take from example line 216 here, grab RX2, grab TX2, and stop there. And that would be your copy selection. And when you pasted a new one in, you would want to increment this duplex logic number in the new copy to be 2, because that's your next available one in the sequence. And change this to RX3, TX3, and then on your pasted copies, RX3 and TX3 as well. Now that's not all there is to it, so you'll have to do a few more things here. And I apologize, I gotta remember where this is at. So if I navigate to user share SVX link events.d, and I've got this bookmarked is why it's already available, so you'll have to create that the first time, and then once you've typed it in up here, navigated to it, just click the add button and it'll be in your quick jump list. But now, so you're in this events.d folder, and you'll notice there's some file names here that probably look familiar. You have the simplex logic TCL, duplex logic 1, duplex logic 2. These correspond to your logics back in the config file that we're talking about over here. Now, the file name is somewhat arbitrary, but it's nice to keep them the same as what you're using in your config file, just so it's easy to figure out what's going on later. But where you've created now a duplex logic 2, I've already got a copy of it here, but let's say we created 3 just for the sake of example. So if you right click, say duplicate, change the number here to 3, and it now just created 3. Now we're almost done. Now if you open this, you'll get this new file over here, and you'll see it says duplex logic 2 here. We need to change this value to a 3. Hit save, and now you're done. So you've now added another duplex logic. And so you can do that with simplex logic, duplex logic, any of the logics that are related to the channel by channel configuration. And that's essentially what you have to do if you want to create virtual channels that use UDP or some other internet protocol, or the SVX reflector, or etc. etc. So with that, that's kind of a quick course on Winscp for the SVX link. If you can get around these files just like I've done here, the biggest part is just knowing where the files are at. And everything that the users typically will need access to is in the user share SVX link, or alternately the etc SVX links folders. And if you can just keep those two in your bookmarks, that'll get you about 95% of the way with what you need to do. Beyond that, I suggest getting onto the groups.io forum, join the SVX links group, and post a question there. There's a lot of us that are active on that group and monitor it actively, so in a lot of situations you'll get a reply very quickly. If you do find some bugs, certainly email them to us, because we do have a custom build, and from there, if we identify that it's something that belongs up in the trunk, we'll post up to the master SVX links. But because ours is custom, we want to know about the bugs that we've created first, so that we can have an opportunity to fix them before we bother everybody with the trunk that may not see the same code that we have. With that, good luck. Thank you.